Welcome friends. Again we discuss several variable calculus. In the last lecture we discussed the epsilon-delta definition of a limit of a function of two variables. In the previous or last year, we see the algebra of limit for the function of one variable. We have to same algebra of limits we have to discuss, but it is for function of two variable. Okay. So our topic is algebra of limits and some theorems and example on these theorems. Okay. So we discuss first algebra of limits. For this what we require? Let f of xy and g of xy be a function defined in a domain D subset of R square, and D contain all nearby points of point AB. Okay, D contain all nearby points of point AB. Then also what we have, limit xy tends to AB, f of xy it is equal to what? Suppose it is equal to L, and limit xy tends to AB, g of xy it is equal to M. Then what we see in the last year, limit of addition of a function is the addition of their limit. Similar definition we have to discuss, that is limit of xy tends to AB, f of xy plus g of xy is equal to what we have to write? It is equal to limit xy tends to AB, f of xy plus limit xy tends to AB, g of xy is equal to what? L plus M. Similar rule we can write it for subtraction. Also second, if or let what we can say C be any real number, then we can write one more rule, that is xy tends to AB, C into f of xy is equal to what? C into L. I am writing directly. So third one, what we can write? Product of the limit xy tends to AB. What we can say that? Product of function f of xy into g of xy, it should be L into M. And what we can take next, fourth one, what we can take? Suppose limit xy tends to AB. What we can write here? F of xy upon g of xy, it should be L upon M, provided what? Provided M is not equal to 0. M must be not equal to 0. So this is the algebra of limit. We can solve some example on this. Suppose first example we have to take, evaluate limit xy tends to 1 to 5x cube minus x square y square. So how we solve this? Just we have to use the algebra of limits. So how we use this solution? What we have to find? We have to find the limit xy tends to 1 to, is it 5x cube minus x cube x square y square is equal to, first use the subtraction of limit rule. So what we can do, limit xy tends to 1 to 5x cube minus limit xy tends to 1 to x square y square. Now what we can take? Now we have to use the rule, this one, multiplication rule. Okay, multiplication with the constant. So what is constant here? 5, you can take limit xy tends to 1 to x cube minus, here is what? Here we have to use the third one. Here we have to use the third one. So you can separate the limit of the function x square into what? Limit xy or into, we can write limit xy tends to 1 to y square. And what should be this? This is, again we can take, write this like this. Power you can take, here it is outside, minus, again you can write xy tends to 1 to x raised to 2 into limit xy tends to 1 to y square. So what should be this? 5 into what? 1 cube. Here minus what? 1 square minus what? 2 square. Is it? So what should be this? What should be this? 5 minus 4, and it is equal to what? 1. So our answer is, limit of this given function is 1. Getting this? Just you have to use the rules, you will get. You can write this. So one more rule you can write. One more rule you can write. Let R belongs to the R be any real number or positive real number, we can say, or the power R be the any real number. Suppose R belongs to the R, okay, and L raised to R belongs to the R, then what we can write? Limit xy tends to AB f of xy raised to R is equal to, what we can write? Limit xy tends to AB f of xy raised to what? R. Okay, so you can solve so many problems on this algebra of a limits. Okay, getting this? So we will go for the next, some theorems. If the limit exists, limit of the function is exist, then it must be unique. Limit is exist, then it must be unique. Okay, suppose f is any function defined in the domain D and limit of the function is exist, then we say that it must be unique. Okay, so second theorem, it is similar. This is for two variable function is also holds. So one more theorem we can write. If f is bounded function and limit xy tends to AB g of xy, it is equal to what? 0. Then we say that the product, limit of the product is what? It should be 0. F into g or f of xy into g of xy, it should be 0. Okay. So what is bounded function? Again, bounded function, f is defined in the domain D, then f is bounded. Then when it is bounded, if there exists a real number m such that what we can say that mod of f of xy, it should be less than m, or less than or equal to m we can write. Then we say that the function is bounded. So what rule we have taken? If it is bounded, if function f is bounded and f is bounded and g limit 0, then product limit is also 0. Suppose we take example, show that limit xy tends to 0, 0, x square sine square y upon x square plus 2y square is equal to what? Okay, so we will solve the problem. So we have to use this theorem. F is bounded function, that is we have to take one function. So what we take? Let f of x y is equal to what? X square upon x square plus 2y square, and we take g of xy. G of xy is what? Sine square y. So our target, first what we have? Limit xy tends to 0, 0, g of xy, it is what? Limit, what we can write? Xy tends to 0, 0, it is sine square y, it should be 0. Sine 0 is 0, and then we can write it is 0. So now we have what we have to show? We have to show f of xy is bounded. So what we can consider? We have so what we have? We have x square is less than or equal to x square plus 2y square, and from this what we can write? X square upon x square plus 2y square, this mod must be less than or equal to 1. What it implies? Mod of f of xy is less than or equal to 1. That means what? F of xy is bounded. F of xy is bounded. Is it? F of xy is bounded, and therefore what we can use? We can use the above theorem. That means by the theorem limit xy tends to 0, 0, f of xy into g of xy, it is equal to what? 0. That is what we can write? Limit xy tends to 0, 0, f of x is x square sine square y upon x square plus 2y square, this should be 0. So by using this property or theorem, we show the limit of this function is 0. So also one more third theorem will be there. If limit of the function is exist in some deleted neighborhood of the f of xy, then it must be bounded. That is, limit exist, then what it implies? F is bounded. If the limit of the function exists, then this must be bounded. Okay? Then we can go for one more theorem, that is sandwich principle or sandwich theorem. So this is a theorem is also discussed for the sequence, and we also discuss for the limit of the sequence and limit of the function. So try to remember this sandwich. Last time I discussed, or I already give some hint to remember this. So there is a sandwich of the function. That is, one function is in between the two function, and then if the endpoints or outside function has a same limit, then we can say that the middle function is also have a same limit. Is it? So what is next theorem? Sandwich principle. Okay, so what we have, if f, g, h are the function defined in the sum domain D, f is less than or equal to g of xy is less than or equal to h of xy, and one more condition, limit of f of xy tends as xy tends to ab is equal to L, and it is the same as the limit of h of xy. Then what we can write, the limit, then the limit of g of xy, limit of g of xy must be same. That is, it is equal to L. That is, if there are the functions like this, then this and this function have same limit, then this middle function must have a same limit. Okay. So what we can solve, what we can take, so take example using sandwich principle. Show that limit xy tends to 0, 0, tan inverse of xy upon xy is equal to 0. So we have to use the sandwich principle, okay, to prove this. So what we can write, we have for one variable function, we have for one variable function. So what we can write, tan inverse of x is equal to, tan inverse of x is equal to what? Series is x minus x cube by 3 plus x raised to 5u by 4 plus and dot dot. Okay. So if we take x is not equal to 0 and divide this series by x, so what we are getting, it is equal to what? 1 minus x raised to x square by 3 plus x raised to 4 by 5, here should be 5u, and if xy is not equal to 0, then what we can write, tan inverse of xy upon what? Xy is equal to 1 minus x square y square upon 3 plus x raised to 4 y raised to 4 upon 5u, and it should be equal. So what we can write, this implies that 1 minus x square y square by 3 is strictly less than tan inverse of xy upon xy is strictly less than 1. But what we can write, limit xy tends to 0, 0, 1 minus x square y square upon 3, it should be equal to what? 1 minus 0, and it is equal to 1, and limit xy tends to 0, 0, it is of 1, it should be 1. That means what? The limit of this both is equal to what? Therefore, limit of xy tends to 0, 0, 1 minus x square y square upon 3 is equal to 1, and it should be equal to what? Limit xy tends to 0, 0, 1, and therefore we can use the by sandwich principle. By the sandwich principle, what we can write? What we can write? Limit of xy tends to 0, 0. What we can write now? Tan inverse of xy upon xy, it should be 1. Okay, so by using the sandwich principle also we can solve the so many problems. Okay, so there are some other methods also for solving the problems. That is, one more method is the polar coordinates. That is, if you take the polar method, polarization or polar coordinate, then also we can solve the using polar coordinates. Okay, limit using polar coordinates. Suppose we have any point, suppose we have r and theta with the polar coordinates of the point xy, then what we can write? X is equal to r cos theta and y is equal to r sin theta. X is equal to r cos theta and y is equal to r sin theta. Here r must be positive. R is always positive. Okay. So what we can take? If we take limit, if we take xy tends to 0, 0, then what we can write? Then r tends to 0 plus. R tends to 0 plus. Okay. Therefore, what we can write? Limit xy tends to 0, 0, f of xy is equal to, it should be limit r tends to 0 plus f of r cos theta, r sin theta. Okay. So polar coordinate, if r theta polar coordinate of xy, then we have to put x is equal to r cos theta, y is equal to r sin theta, and if you take limit xy tends to 0, 0, then we have a limit r tends to 0 plus, and then limit of the function f of xy is equal to the limit of the function r and theta. So we will solve some example using polar coordinates. Find the limit of the following function. Limit of the following. So first example, limit xy tends to 0, 0, 0, 0, x cube plus y cube upon x square plus y square, and second example we have to take limit xy tends to 0, 0, sin x square plus y square upon x square plus y square. Okay. So we can solve the two examples. So my point of view, when we have to use the polar coordinate, keep in mind, by my observation, if denominator here x square plus y square, then only you use the polar coordinates. You go for the polar coordinate if denominator is x square plus y square or something like this. But keep in mind, if there is x square plus y square, then go for only the polar coordinates. Okay. So first example solution. So what we can put x is equal to r cos theta, y is equal to r sin theta. First example, so what we can say, limit xy tends to 0 0, x cube plus y cube upon x square plus y square, it is equal to, so what we have to write here now, it is r tends to 0 plus, okay. Then what we can write, r cos theta cube plus r sin theta cube upon what we can write, r cos theta square plus r sin theta square. So what we can take, r cube, x cos cube theta, r cube sin cube theta, r cube we can take common. So r tends to 0 plus, so r cube up into what is remaining, cos cube theta plus sin cube theta. And here what we can say, r square cos square theta plus sin square theta. Now cos square theta plus sin square theta, it is equal to what, 1, and then what is remaining, limit r tends to 0 plus, what should be written, this r square get cancelled with this, so remaining r into what, cos cube theta plus sin cube theta upon what is remaining, 1, and then what we can write, 0 into cos cube theta plus sin cube theta, and this should be 0. So what is the limit of the first function? Limit of the first function is 1. Okay. So similarly you can solve second one. It is also very simple. Find limit xy tends to 0 0, 3x square y upon x square plus y square if it exists. That is, you have to find the limit if it exists. Now think about this. How we solve this example? So many methods. Can you solve using by path? Using path, suppose you take x is equal to 0 path, then what should be the limit? What should be the limit here? If you take y is equal to 0, then what should be the limit? If you take x, y is equal some other path, then what is it possible? What I am saying, or what I told that time, use the limit along the path only for the not existence of a limit. But here what we have to find? We have to find the limit. Therefore we are not going for this method. Polar method, yes, you can solve this by polar method, because here also x square plus y square is in the denominator, so it is possible to use, or you can use the polar method here. Okay. So can you solve this by using the epsilon delta definition? Yes, definitely. So we will go for the solution. So we have to prove, what we have to prove? Is there any other method? Is there any other method? Yes, we can say theorem also we can use. Product of the function, that is one function you can show it is bounded and you can show other limit is 0. So try this method by home. So what is homework? You have to solve this example by the polar and by the theorem. Which theorem? By the theorem. Which theorem you have to solve it is? It is by one function is bounded. Which function you can take? Suppose you can take f is equal to, f you are taking 3x square upon x square y plus y square. Is it? If you take this one example and it is f and g it is equal to y, then you can show that this limit is 0. You can show that this limit is 0. It is, I think, very easy to solve this. Okay. Well, I will give you proof of the limit of this function by using epsilon delta definition. We have to prove, what we have to prove, limit xy tends to 0 0, 3x square y upon x square plus y square is equal to 0. So why we are taking here 0? Because if you take any path you will get the limit 0. That is, you just guessing the limit may be 0, then you can take this method, or this method is useful. Theorem is very simple method. But we can solve so by epsilon delta method, that is for every epsilon greater than 0 we have to find, what we have to find? We have to find a delta greater than 0 such that what? 0 less than or equal to x minus 0 square plus y minus 0 square is less than delta. Then what we can say, that mod of f of xy minus 0 is equal to 0. What we take here, f of xy, what is f of xy? What is f of xy? 0 is less than, what is here? X square plus y square is less than delta. Then what is f of xy? What is f of xy here? F of xy we are taking 3x square y upon x square plus y square. So what is f of xy? 3x square y upon x square plus y square minus 0. It is less than epsilon. This should be less than epsilon. Okay. And what it implies? Take any epsilon greater than 0. Take any epsilon greater than 0. Then what we can say? Then what we have to find? We have to find the delta. We have to find the delta. Be given, epsilon be given. Then what we can write here? We have x square is less than or equal to x square plus y square, and this implies that x square upon x square plus y square, it is mod of this is less than or equal to what? This is less than or equal to 1, and this implies that mod of 3x square y upon x square plus y square minus 0, it should be, we can write 3x square mod y upon x square plus y square, and this should be less than or equal to 3 mod of y. Here we can say star by star. Okay. And what we can write? What we can write? This is equal to what? 3 into square root of y square, and it is less than or equal to 3 into y square x square plus y square. So this is you are using by star. Okay. So what we can write? If we take epsilon or delta is equal to epsilon by 3. Okay, this is our delta, epsilon by 3. Then what we are getting? Then we can write here, then mod of 3x square y upon x square plus y square minus 0 is strictly less than 3 square root of x square plus y square is equal to 3 into what? Epsilon by 3. This should be epsilon, and that is mod of 3x square y upon x square plus y square minus 0, it is strictly less than epsilon whenever what? Whenever square root 0 less than square root of x square plus y square is less than delta. This is less than delta, and therefore our problem is finished. Okay, so what is important here? We have to take the delta is equal to epsilon by 3. Okay, so this problem we can solve by so many methods. Just you have to practice this. So practice all examples. Thank you very much.